So this problem is dealing with car objects. So we got a car class. Hey Jack, let's screen share. And there we go. Screen share. Go live. Create an application named Car Demo that declares at least two car objects and demonstrates how they begin incremented using an overloaded plus plus operator. This is something that we haven't covered, but I'll cover it. I don't think we have a lab with this, but nonetheless, you'll see how that works. Create a class that contains a model and a value for miles per gallon. So we got a car model and we have miles per gallon. Two overloaded constructors. One constructor accepts parameters for the model and MPG. The other accepts a model and sets MPG to 20. Overload a plus plus operator. And the car application creates a car using each constructor and displays the values before and after the incrementation. Add new project. Car demo. A lot of times in the project name you just call it demo, like we're demonstrating cars in the project, right? So a lot of times you might call the application that runs a class a driver. That's another term, not to relate to car drivers. You could call it, movie driver, et cetera, et cetera. But demos probably a little more understandable. So let's create a car class, add a class called car, mark that class as public, and we're going to make two fields. One was miles per gallon, the other one was model, like car model. And can you get, most of the time, miles per gallon, they're not really rated at half miles per gallon. They round up, they round down, whatever they do. I don't normally see cars with 33 and a half miles per gallon, right? I don't tend to see that. So we'll just make MPG an int and figure they're gonna have to round up or round down, whatever. It's a whole number. Two constructors. So what are these called? These are our instance fields. I'm going to add some things to this just because I think you guys are at a point where we can do that. Let's go ahead and make our constructor. Remember, a constructor is a method with the same name as the class. What is the name of our class? Of course, it's car. Has an access modifier of public. It has no return type. So there's no void or double or anything like that. This right here is called the default constructor. You get it for free. In other words, you don't have to code it unless you start overloading like we are going to do. It says another constructor with two parameters, which is both the model and miles per gallon. What you do in a constructor typically is you initialize your instance fields. Remember, when I say initialize, I'm saying you put a value in them for the first time. That's what it means to initialize a variable. So we set the instance field, the variable up top, equal to the parameter, which is the value coming into the constructor, the value that's being passed from the form. Same thing here. We set the instance field equal to the miles per gallon. So now we have two overloaded constructors, but we're going to make another one. Per the instructions, it says it accepts a model and sets the miles per gallon to 20. So it's kind of like, hey, if you use this constructor, automatically set the miles per gallon, just hard code a value of 20. Okay, so you can kind of set your own miles per gallon, or for whatever reason, if you don't set a miles per gallon, it's going to be default to 20. Keep in mind, if you use this constructor, the model will be null and the miles per gallon will be 0. Okay, that's kind of like the default using the default constructors. The defaults for strings are nulls, the default for ints are 0, double 0.0, etc. Then it talks about overloading the plus operator. Now, this is not something that I do over every day, but we can hit the Microsoft Docs and see kind of the syntax for it. Okay, let's talk about what is operator overloading. Well, I can give you an example pretty easily, and that the plus symbol, like if I say int x equals 1 plus 1, or I'll say string name equals Evan plus Gudmstead. Okay, if I'm zoning in on this plus operator, this plus operator is doing two different operations depending on the type of data that it's interacting with. In this case, we're doing addition. In this case, we're doing what's called concatenation. We're adding strings together. So the plus operator, the symbol, the plus symbol, is overloaded. It does different things depending on what it's operating on. Okay, so what does it mean if, for example, you add cars together? Like if I had two car objects like car C1 and C2, well, you could, in theory, overload the plus operator that says, hey, if I add car 1 plus car 2, what is the results of that? Right? So you could overload the plus operator to define what it means to add these classes together. Because out of the box, there is no definition of what it means to add cars together. It just doesn't make sense. The same thing, another operator is the plus plus operator. The plus plus operator, what does it mean if you have a car object like car C1 and then somewhere in your code you go C1.++? What does that mean? You got to define it, right? So these operators like plus, minus, divide, plus, plus, they can be overloaded, and that's part of this problem, is to define an overloaded plus plus operator. Now the syntax for that, this is like an example of overloading plus, overloading minus. I don't even know if they have you could see there's overloadable operators, not overloadable operators. So these are, here we go, this is a good chart. Overloadable unary operators like plus plus. So you can overload the plus plus. So what does it mean to overload plus plus? Now, kind of going back. Again, I don't do this every day, but I think you have the syntax of public, the keyword static, the data type of car, because this is a fraction class, so we're gonna public static car operator plus plus is the syntax. Public static car operator plus plus, and you take in a car object, and we have to return a car object. Now I might be able to get away with returning void here, but let's return a car just because that was the syntax in the documentation. And what I'm going to do is I'm going to return. Now I don't have any way of I haven't flushed this class out yet. What I mean by flush the class out yet, we have two constructors, we have parameters, but we don't have a way of updating the miles per gallon. So we don't have, once we set the miles per gallon in the constructor, we don't have a way of updating the miles per gallon. So the way that you can do that is with properties. So I'll go ahead and make some properties for model and public int miles per gallon. Get the miles per gallon and set the miles per gallon. And so you pass in a car object into this method, and I could probably write this syntax in less lines, but let's just start off by reading the current mile per gallon, and then setting that up by 1. So here we read the miles per gallon, we increase the miles per gallon by 1, and then we're just going to return car. Okay, so we pass in an object into this method, the data comes in, the car object is coming in. We read the current miles per gallon by using the property car MPG. We then increase the MPG. You know, maybe what you could do is, again, you could condense this syntax, but this is nice and readable, I think. So this is new. This is overloading the plus operator, and what does it do? It makes the miles per gallon go up by 1. Somehow, you know, Volkswagen got in trouble for lying about their MPGs on a lot of their cars several years ago. Called it Dieselgate, right? Because these diesel cars were getting like 100 miles per gallon. It was just a lie. So Volkswagen somehow magically increased their miles per gallon. So that's what this is going to do, right? We're going to somehow say our cars are now getting better miles per gallon. You guys are looking at me with blank stares. You guys don't remember that? Dieselgate from a few years ago? Yeah, VW got in all sorts of trouble.
I think I was in my last year of high school.
Yep. Okay. So this is our class to make cars. We've got some properties, and we've got an overloaded plus operator. Let's go ahead and demonstrate this. And I'll do a little user input because I know that that's been requested on a time or two. I'll create cars, button create cars. And what do we need? We need a text box for the model. And a text box for the miles per gallon. Copy paste. Come on, Visual Studio. Copy, paste. Text model, text miles per gallon, button called create cars. So I'll say car, my car is new car. Now, because I've got the text box, I could say my car dot model equals text model dot text. My car dot MPG equals convert to int 32 text MPG dot text. Okay, so I just want to demonstrate this is a way of creating an object. The object is a car using the first constructor. The first constructor was the default constructor. Okay, I'm going to use all three of my constructors here. Creating a car object using the default constructor. That's this piece right here. That's calling the method that sets my car's MPG to 0 and setting the model to null. Okay? But right away, I update the model using the properties. So I'm going to insert car data using properties. The set blocks of the properties. So I want to put a breakpoint in here. I just want to show you how this executes line by line. And let me run the right one. So notice I put a breakpoint in and I click the start with debugging. And I'm going to say Tesla and whatever. There is no gallons of gas, so that's a bad demo. So we'll see VW Jetta, because they were in Dieselgate and they were like something stupid, like 70 miles per gallon. Create a car. Okay, so notice this is actually going to step through my code line by line. This calls the default constructor. Literally, you see this go into the car class and calling the default constructor. Now you're going to see the model. It actually skipped over, which it shouldn't have, but the model was just set to VW Jetta and the MPG. So what this does is it goes into the model, into the set block. So it runs line 37. Line 37 sets the model instance field equal to value. Value is being passed in as VW Jetta. Jetta? Yeah. Am I saying that right? That's weird. Volkswagen Jetta. It's a weird word. So coming from the text box, the text property being passed into value, and from value it sets underscore model equal to VW Jetta. So ultimately it's all about the instance fields. We're changing that instance field for that car. And the same thing for MPG. When I set the .mpg, it's going to call the set block of MPG. So it sets in the value of 70 comes in to the set block. It sets the instance field equal to 70. Okay, so that is using this is using the default constructor. Now let's create another car. Car your car equals new car. What kind of car do we drive here? Someone?
Civic.
A Honda Civic. And what is the miles per gallon on that?
Couldn't tell you.
We're just going to say 30. Okay, this is creating a car object using the toParam constructor. Okay, now let me put my breakpoint here. I'm going to run this app again. I'm going to show you how it calls. Again, my car is a VW Jetta, and the MPG is 70. But notice I skipped over that. I'm hitting the breakpoint, and look where it goes. It goes to the constructor with two parameters. And notice again in this constructor, we're setting the model equal to Honda Civic. We're setting the MPG equal to 30. Right? So it's all about the instance fields. We're using the constructor or the properties to set the values in those instance fields. Okay, and the third one, so I've got my car, which is an object. I've got your car, which is an object. I'll make a third car. Car, another car is new car. And I just want to demonstrate using that. Notice right here where I'm clicking my mouse, it shows me I've got 3 overloads of this constructor. I'm just showing you using all 3. Okay, when I look at this one, it takes a string for the model. So I'll just say
Toyota Camry.
Toyota Camry. Is it ERY? Now, because it's a Camry, it's using this one. Keep in mind, the miles per gallon is automatically set to 20. Okay, I'm also going to write a toString method because I public override. I'm just a big fan of the toString method. Oops. Because toString can be used to return a whole bunch of data all at once. So let's return the model and the MPG for this car. This car's model is underscore model and has a miles per gallon of MPG. Okay, so now I've got a toString that I can call on all three of my cars. And so here's what I'll do. I'm going to put in a line break 2 on each one of these. And one output label. And auto size. Where's my auto size? So I think
it's like a little bit below design, so if you scroll down.
There it is. Good eye. Thank you. So there's auto size. I'm gonna get a nice big label here. So I'm gonna do label result dot text equals my car to string label result dot text plus equals your car to string label result dot text another car to string. So just putting data in, pulling data out 3 different ways. And so if I say Tesla has 0 miles per gallon, this car's model is Tesla, MPG of 0, Honda Civic of 30, and Toyota Camry of 20. Now, here's what I'll do. I'll say my car plus plus. Okay, so that's an example of overloading the plus plus operator. What does that do? Again, we had to define what that does. Otherwise, this line of code would not work. I don't know if it wouldn't compile or if it just wouldn't do anything worthwhile. But we have now defined what it means to take a car object and apply the plus plus operator. And so what I'm going to do, label result dot text plus equal, and I'll say after diesel gate my car's MPG is, and then I'll say my car dot MPG. Okay, and I can actually, because this will take it up by 1 at a time, if I maybe go up 5 miles per gallon, something like that. And it's not working, but it is working. I mean, it's doing something. It's just not the desired effect. So let's see. My car.
You did it 5 times.
Oh, it is working. Yeah, I went from 5 to 10. Okay, that's right. I just went from 5 to 10, so I increased 5 times.
It's really a scandal when Teslas have
a miles per gallon. So I should have stuck with my VW Jetta again. They're the ones that got in all sorts of trouble for this. So if I say 70, it goes from 70 to 75. Okay. That's a good, just one demo. I'm going to stop here. You guys can start working on labs. There's definitely more to cover in this chapter, but we'll just take a piece at a time.